So today, guys, we're working through 8C, differential equations. It's only 5 questions, so it's a bit shorter than our exercise yesterday. So you may find you'll finish earlier and there'll be some time to kick back on 8B. So a differential equation is a relationship between a function and its derivative. Okay, that's what a differential equation is. It's a function about a derivative. So we're going to show that x to the power of 3 is a solution to this differential equation. Okay, so all we're doing is, this is the differential equation, and I think that says y because x to the power of 3. What we want to do is integrate both sides, okay, with respect to x. And so if we do that, I'm going to write it out here. Okay, I'm going to write out what we're doing. We're integrating both sides with regards to x. And we're going to get y equals, the integral of 3x squared is going to be 3x to the 3 on top of 3, which plus c, which simplifies to x to the power of 3 plus c. Alright? So that means x to the power of 3 is a solution, and in that circumstance, the value of c is 0. There's lots of possible solutions, but in this particular one, c is 0. All right, so all you're doing with those questions is performing some integration to show that there is an appropriate solution. Okay, let's have a look at this one. The derivative of y with respect to x is equal to 2 times x times y, take away 2 lots of y. Okay, so there's lots of functions that could satisfy this differential equation, and we're presented with this one, and it says, show that this is a solution to this differential equation. Okay? So there's 2 ways we can get there, because if we're going to integrate this, all right, it's not going to take us to here, but we can differentiate this and show that if we differentiate this, we can end up with something like that. So that's the path we're going to take. All right? Remember that link between integration and differentiation. So in order to differentiate here, we're going to have dy on dx is equal to k. K is just hanging out. We've got e to the x squared take 2x. So that's e to the f of x. And when we differentiate e to the f of x, all right, the rule is it goes to f dash of x, e to the f of x. So in our circumstance here, we're going to have 2x take 2, e to the x squared take 2x. All right, that's what it simplifies to. And so what does this become? I'm going to expand this. I'm going to distribute the 2x and the minus 2. Okay, and what do we notice? Well, e to the x squared take 2x is y. Alright, e to the x squared take 2x is y. Hang on, I need to distribute the k as well. Well, let's put the k there. Sorry. 2xk e to the squared take 2k. Y is k e to the x squared take 2x. So here we can simplify this to be 2xy take 2y. Alright, and so we can see our differential equation obtains. Alright, so rather than integrating to show that it's a solution, we differentiated this to show that it satisfies this differential equation. Okay? So what's it say to do next? Sketch the solutions for k is 0, plus or minus 1, plus or minus 2, plus or minus 3. I haven't put room there for us to graph it because that's all you're doing in this exercise. We're going to graph this function. That's the solution. We're going to graph this function. Wait, does it say sketch the solution? Sketch the solution for. Yep, so this is the solution for, and then we're given the values of k. So for example, I mean, if k is 0, the line's just going to be the x-axis. Let's go for when k is positive 3. We're going to have the function y equals 3 e to the power of x squared take 2x. Okay, so that's what it looks like when it's positive 3. And all you're doing there is changing the value of k, aren't you? So we've got 2, we've got -2, we've got -3, and that's what I want you to do. Sketch the solution. All right, it's a solution to this differential equation. This differential equation, all right, the derivative satisfies all of this family of functions. Okay, it's a family of functions because the value of k could be anything. All right, doesn't matter what the value of k is. This is a solution to that function, differential equation. All right, find the particular solution through the point 1 and 1 on e. So I'm going to jump up here. We have y equals k, e to the x squared take 2x. And we're told when x is 1, y is 1 on e. When x is 1, y is 1 on e. So this is just a matter of substitution to determine the value of k. So we're going to have 1 on e is equal to k, e to the 1 take 2. Just by substituting in the x and the y values. And we process this. Okay, so we establish in this circumstance, when it passes through the coordinate 1 and 1 on e, the value of k is 1. Okay, find the equation of the tangent at this point. So a little bit of a recap of some applications of calculus. For a tangent, it's the equation of a line. All right, it's y equals mx plus c, isn't it? So what are the things we need? We need the point of contact and we need the slope. Okay. Point of contact we've established. It's touching at the point x is 1, y is 1 on e. And we need the slope. Okay, now we don't have to do any differentiation here because we've already done it. We've done it over here. This is the derivative function. Okay, it's 2xy, take away 2y. I'm going to write that here. dy on dx is equal to 2xy, take away 2y. Now this is the beauty of differential equations in spec maths. All right, is we don't need to substitute the x value into the original function to determine the y value. Okay, we've got the y value here. I mean, that's what you get when you substitute it. We've already done it. So we're going to have here, I'm just substituting these coordinates into the differential equation. The slope depends on both x and y. The slope is going to be 2 times 1 times 1 on e, take away 2 times 1 on e. Slope is 0. Okay, so the slope is 0. So that means the equation of the line is y equals 0x plus c. All right, and we have when x is 1, y is 1 on e. All right, so 1 on e is equal to 0 times 1 plus 1 on e. So our value of c is 1 on e. All right, that's what's going to have to be true. So therefore, the equation of the tangent is y equals 1 on top of e. It's not dependent on x. It's the equation of a horizontal line. Let's have a quick sketch of it so we can see it. So we have in this circumstance 1. Why is it not tangent? Read the x squared. Oh, the take 2x is supposed to be up the top.
Does not like you, sir.
So it's really not liking me, is it?
Put it in brackets, maybe.
There we go. Alright, so tangent at that point, just touching. Okay, any questions about that process up there? So it starts off a bit of integration, a little bit of differentiation, a bit of both. So yeah, let's give it a crack.